So here's a question on graphing a quadratic. So you'll notice here that the instructor got the initial equation and she simplified it. So I actually wrote this exact equation down here. And now our goal is to graph this quadratic. So just to summarize, if you notice that your equation, the greatest exponent is power to the 2, then we can assume that the shape of this equation will look like a parabola. So you'll notice that this teacher also drew a parabola. But let me just draw one here. Here's a parabola. So unlike Algebra 1, where you draw a lot of lines, starting from Algebra 2, we start graphing quadratics, which are equations with the power of 2, and we end up getting this shape called the parabola. So just some qualities of a parabola is that when it opens, it goes towards the same direction. So you'll notice right now this parabola is opening upwards. A parabola can also open downwards, so it can also look like this. They're both parabolas. So I don't want you to assume that only parabolas look like this, but it can open upwards or downwards. So another quality of a parabola is that it has something called the vertex. It's basically the point where the parabola starts. So that's the vertex, that's the vertex. And once you have the vertex, you can kind of see the shape of your parabola. So if I were to refer back to this example, this teacher, this point right here would be the vertex. So right now what we're going to do is we're going to try to graph this equation. So in order to graph the equation, the first thing you need to do is figure out what's the vertex or where it is. So I just kind of pushed my notes to the side. So to figure out the vertex, they do provide a formula. So you'll notice a vertex is a point. So vertex is a point. And a point has a x coordinate and a y coordinate. So I need something in here and something in there. To figure out the x coordinate, there's a formula for it, and the formula is -b/2a. And you'll notice that the teacher here also used it as well, -b/2a. But you might wonder, Miss So, where's the b coming from and where's the a coming from? So referring back to this equation, this is right now set to standard form. The reason why it's set to standard form is because it's in the format y is equal to ax² plus bx plus c. This format is called standard form. So if I were to refer to the standard form template, my a is equal to, let's see, what number do we have in front of x²? We have a 1, so a is 1. B is, so we have b right here. B is, so you don't want to just say 6, but we also want to take that negative with us. So b represents -6. And then we also have a c here. C is equal to, and you'll notice it matches up with the 10. 10. So in order for us to use this orange formula for vertex, we're going to use the b and the a. Let's plug it in right now. So we have -b, so my b is -6. I want you to notice that I kept this negative that was in front of the b, and then I also plugged in -6. So I didn't ignore one of them, I kept both of them. So the negative in front of the b, and then the -6 for the b. All over 2 times a, which is 1. So I'm going to simplify this. So a negative and a negative turns positive, so positive 6 over 2 equals 3. So now I know that for this vertex here, so I'm going to erase this x, I know that it's a 3 because I just used the formula for vertex. And you'll notice here, even the teacher from Edgenuity also obtained 3. So you might wonder, Miss So, we have the x, how do we get the y? How do we get this point? Is there a separate formula? The answer is there is no separate formula because we don't really need one. If you refer back to this equation right here, you'll see variables x and y. But now, after all this work we did in orange, we were able to figure out what x was, because this whole time we were solving for the x. Since we obtained the x, if we actually substitute this 3 back in here, we'll be able to solve for the y. So to find y, we're going to substitute the x equals 3 to solve for y. So let's do that right here. So I'm going to scroll a bit. I'll do it in blue so you can see the work. So right now my equation is y is equal to x squared minus 6x plus 10. And now every time I see x, I'm going to substitute it with 3. So I have y is equal to, I'm just going to color code it so you see it. Okay. 3 squared minus 6 times the 3 plus 10. So you'll notice now on my right side of this equation, they're all numbers. So I'm going to simplify everything so I get y is equal to a number. So we have y is equal to 3 squared is 9 minus 6 times 3 is 18 plus 10. Y is equal to 9 minus 18 is negative 9, then plus 10. Y is equal to 1. So now that y is equal to 1, I'm just going to erase this y right here. 1. So now my vertex is at 3, 1. So I'm just going to refer back. Let's see. To this example. Okay. Well, I'm just going to graph my own. Let's go. Here's my graph. And my vertex is at point 3, 1, 2, 3. So unlike Edgenuity, I'm just going to jump by ones. 1, 2, 3. Vertex is at 3, 1. So I'm going to get that point, 3, 1. So from here, I know I mentioned that a parabola can open upwards or downwards. So if you go back to the original equation, you'll notice that the a, our first term, is positive, right? A is equal to a positive 1. So if it's positive, it's going to open upwards. So if I were to make a very simple sketch, so this isn't accurate, but if I were to make a simple sketch, I'm going to open it upwards, and this would be a sketch of the graph for this equation.